Hello, everyone. Welcome back to PodBites, where we break down complex medical topics into bite sized pieces, perfect for your commute, coffee break, or whenever curiosity makes the call. I'm Ismail Abdullah, a neuro enthusiast and your host for today's episode, and I'm joined by my best friend, Amro Badra.
Hey Ismail, I'm very excited for this one. Today we're going to discuss cranial nerves 5 and 7. But honestly, they're not just any cranial nerves. They're the true bosses behind every blink, bite, and smile.
Exactly. And today we're going to walk you through their pathways, branches, what they supply, and it's not PodBites without some fun clinical tips. Plus, we've got a few mnemonics up our sleeves to make all them tricky branches stick.
And don't worry, we'll try to keep it simple. By the end of this episode, you'll totally own cranial nerves 5 and 7.
All right. Are you ready, Amro? Let's dive right in with cranial nerve 5, the mighty trigeminal nerve. This is a pretty big one.
It really is. Cranial nerve 5, aka the trigeminal nerve, is a huge nerve. It's mainly responsible for facial sensation and the muscles of mastication. Plus, it receives somatic sensation from the anterior two-thirds of the tongue and even helps dampen loud sounds via the tensor tympani.
Wow, overachiever much. So, you're telling me it's sensory for the face and interior tongue, but it's also motor for mastication and tensor tympani. The tri in trigeminal stands for 3 divisions.
Exactly. V1, V2, and V3, which are the ophthalmic, maxillary, and mandibular divisions.
All right, let's hit it with the first division, the ophthalmic division.
The ophthalmic is purely sensory. It exits the cranial cavity through the superior orbital fissure and immediately splits into 3 major branches: the frontal nerve, the nasociliary nerve, and the lacrimal nerve.
And can you tell us what does each one of them do?
The first branch, the frontal nerve, gives rise to the supraorbital and supratrochlear nerves and supplies the forehead and scalp.
You can remember frontal nerve because that's the area over your frontal lobe.
Then we have the nasociliary nerve, which branches into the posterior ethmoidal, anterior ethmoidal, and long ciliary nerves.
You can actually remember the branches just from the name of the nerve itself. Nasociliary. First, naso. Think of the nose. What's at the roof of the nose?
The ethmoid bone.
So, the first 2 branches are the interior ethmoidal and posterior ethmoidal nerves. The second part of the name is ciliary because it gives off the long ciliary nerves to the eye.
This is a really nice way to remember them. That's why the nasociliary innervates part of the eyeball, nasal cavity, and ethmoid sinuses.
We talked about the first 2 branches of the ophthalmic division, which are the frontal and nasociliary branches. The last branch is the lacrimal nerve, which supplies the
lacrimal gland and part of the lateral upper eyelid. You can easily remember that the lacrimal nerve supplies the lacrimal gland, and then just remember or picture that the lacrimal gland is close to the lateral upper eyelid.
Okay, so basically, the ophthalmic division of the trigeminal supplies the forehead, eyeball, nose, and the lacrimal gland.
Yup, notice how all these things are found in the upper third of the face?
Now let's go 1 floor down to V2, or the maxillary division, which is responsible for the middle third of the face.
The maxillary division is also purely sensory. It exits the skull through the foramen rotundum, enters the pterygopalatine fossa, passes through the infraorbital fissure, travels along the infraorbital groove, and exits at the infraorbital foramen.
That sounds like an obstacle course. A silly way to remember it is just imagine that the foramen rotundum is a rat hole. So foramen ratundum. Then he enters the pterygopalatine fossa. Here, you can think of Ratatouille, the wonderful rat chef, because he had a terrific taste palette. And finally, after the pterygopalatine fossa, it enters the orbit through the infraorbital fissure, which lies deep inside the eye socket. Inside the orbit, it travels along the infraorbital groove. This groove is like a secret tunnel in the floor of the eye socket, leading toward the surface of the face. That's where the nerve exits through the infraorbital foramen. This is around the upper part of the cheeks because we know the maxillary nerve supplies the middle part of the face, so it exits out through the cheeks, which are in the middle.
So it's infraorbital fissure, then infraorbital groove, then infraorbital foramen. Great, that covers it pretty well.
Let's go to the branches of the maxillary division.
First, we have the ganglionic branches.
These go to the pterygopalatine ganglion.
Then, the posterior superior alveolar nerve.
This goes to the upper molar teeth because it's called posterior for molar, superior for upper, and alveolar for teeth. So in other words, upper molar teeth nerve, but more fancy.
After that, we have the zygomatic nerve.
Going to the cheek and part of the orbit because when you hear the word zygomatic, you should think of the cheeks.
Next are the greater and lesser palatine nerves.
From the name palatine, we know that they go to the hard and soft palate.
And finally, we have the infraorbital nerve, which splits into labial, palpebral, and nasal branches.
Mid-face, upper teeth, palate, and cheeks. Got it.
Yeah, so V1 is for the upper face. V2 is for the mid-face, including your upper teeth.
And that leaves us with V3 for the lower third of the face.
Here's the interesting part. The first two were purely sensory, but V3, aka the mandibular division, is mixed, both sensory and motor.
Wait, the mandibular division is motor for mastication, right?
Yes, you're right.
All right, walk us through its branches.
First of all, it exits the cranial cavity through the foramen ovale and splits into two divisions, anterior and posterior.
So the mandibular division of the trigeminal nerve gives out an interior division and a posterior division.
The anterior division is mainly motor, while the posterior division is mainly sensory.
You can remember that A is for action, so the interior is mainly motor, and then P is for perception, so the posterior is mainly sensory. Let's start with the interior division.
The anterior division gives 4 branches. 3 are motor and only 1 is sensory. The sensory branch is called the buccal nerve, giving sensation for the cheek mucosa. The rest of the branches of the anterior division are, as we said, motor. We have the deep temporal nerves to the temporalis muscle, the masseteric nerve to the masseter muscle, and finally, the lateral pterygoid nerve to the lateral pterygoid muscle.
So the interior division of the mandibular division of the trigeminal nerve has 1 sensory branch called the buccal nerve, and the rest are motor for the muscles of mastication. Now, let's go to the posterior division, which is mainly sensory.
The posterior division gives off 3 branches. First is the lingual nerve for somatic sensation of the anterior 2/3 of the tongue. Then, the inferior alveolar nerve for the lower teeth and the chin. This one exits as mental nerve. Remember mental for the chin. And last but not least, the auriculotemporal nerve, going to the ear and the temporomandibular joint. Notice that auricular in the name is for ear. The auriculotemporal nerve also carries parasympathetic fibers from the otic ganglion, going to the parotid gland.
So I have a question. Does the lingual nerve, our first branch, also carry taste sensation, or is it only somatic?
The lingual nerve itself is only for somatic sensation, but some taste fibers come from the chorda tympani, a branch of the facial nerve, will join the lingual nerve and hitchhike with it.
Oh, okay. So the lingual nerve originally is for somatic sensation of the interior 2/3 of the tongue, but it carries taste fibers from chorda tympani.
Exactly.
All right. So the posterior division of the mandibular division of the trigeminal nerve gives us the lingual nerve, the inferior alveolar nerve, and the auriculotemporal nerve.
Yes, and don't forget this is the posterior division. The anterior division that we talked about before supplies the muscles of mastication for opening and closing the jaw. Those are the masseter, temporalis, medial, and lateral pterygoids.
All right. Quick recap. V1, or the ophthalmic division, is for the forehead, eyes, and the nasal cavity. V2, or the maxillary division, is for the midface, shiny upper teeth, and cheeks. V3, or the mandibular division, is for the lower face, jaw movement, lower teeth, and tongue sensation.
And remember, V1 and V2 are purely sensory, but V3 is both sensory and motor to help you chew.
All right, PodBiters, now test yourself if you got the functions right with some practice questions.
First question. What nerve supplies the somatic sensation to the anterior 2/3 of the tongue? The answer is the lingual nerve, which is a branch of V3, is for somatic sensation, but the taste part is carried by the chorda tympani from cranial nerve 7. Next question. A patient has numbness over their forehead and scalp. What division of cranial nerve 5 is affected? That would be V1, the ophthalmic division, which supplies the upper third of the face.
All right, Amro. That was a big chunk of today's episode. Now let's flip the page and talk about cranial nerve 7, the facial nerve, my personal favorite.
The facial nerve is both motor and sensory, and a little bit of parasympathetic too.
Multitasker, I see. What's the general role of the facial nerve?
For its motor function, the facial nerve is responsible for the muscles of facial expression and the orbicularis oculi muscles for eye closure. It also innervates the stapedius muscle, which stabilizes the bones in your ear to protect against loud noises.
Okay, so the facial nerve is motor for facial expressions, eye closure, and the stapedius muscle. Does it carry any sensory function?
For its sensory function, it takes the taste sensation from the anterior two-thirds of the tongue via chorda tympani.
This is the one that joins the lingual nerve from the mandibular division of the trigeminal, right?
That's right. When it comes to the anterior two-thirds of the tongue, taste is by chorda tympani from the facial, while somatic sensation is by the lingual nerve from V3. So we talked about the motor and the sensory innervations of the facial. And finally, the facial nerve also has a parasympathetic function for the lacrimal, the submandibular, and the sublingual glands.
So the facial nerve has parasympathetic innervation of all the salivary and lacrimal glands in the face, except for the parotid gland. I know that the facial nerve takes a very intricate path, so let's go over that. Where does it even begin?
So first, the facial nerves start at the brainstem, specifically at the pontomedullary junction. That's the area right between the pons and the medulla. From there, it travels together with its buddy, cranial nerve 8, the vestibulocochlear nerve, and they both enter the internal acoustic meatus.
So facial and vestibulocochlear nerves are like the best friends heading into the internal acoustic meatus.
Exactly. Both nerves go into the internal acoustic meatus, which is in the petrous part of the temporal bone.
Okay, so now they've entered the skull. What happens inside?
This is where it gets really interesting. Inside the facial canal, the facial nerve bends sharply at something called the geniculate ganglion.
Geniculate ganglion is like a bunch of neurons?
Yup, it's basically the sensory hub where cell bodies for taste are sitting. This bend of the facial nerve is called the geniculum, aka the genu, because genu means knee, and this bend looks like a knee.
So the facial nerve takes a little pit stop and forms the genu at the geniculate ganglion. And then what?
After the bend, the facial nerve gives off some really important branches. First, it gives off the greater petrosal nerve. This one is responsible for carrying the parasympathetic fibers of the lacrimal gland for tears, as well as fibers of the nasal gland for mucus.
Okay, facial nerve gives off greater petrosal nerve for tears and nasal secretions.
Then a bit further down, the facial nerve gives off the nerve to stapedius. Remember, stapedius is the tiny muscle that protects your ear against loud sounds.
Oh, a clinical tip. If the nerve to stapedius is damaged inside the facial canal, patients can get hyperacusis, where they'll hear sounds as painfully loud.
You got it. And then it gives off the chorda tympani. Very important. This nerve carries taste fibers from the anterior two-thirds of the tongue and parasympathetic fibers to the submandibular and sublingual salivary glands.
So basically, the facial nerve gives off the greater petrosal nerve, nerve to stapedius, and chorda tympani, all before it even leaves the skull.
Yup, the facial nerve is doing the most while it's still inside the bone.
And how does it finally get out?
After all that branching inside the bone, the main trunk of the facial nerve exits the skull through the stylomastoid foramen.
That's near the mastoid and styloid processes of the temporal bone, right?
Exactly. Once outside the skull, the facial nerve gives off even more smaller branches immediately. It gives off the posterior auricular nerve, which goes to muscles around the ear and the occipital part of the scalp.
So from its name, the posterior auricular nerve goes posteriorly to the occipital part of the scalp and goes to the auricle or the ear.
At the same point, with the posterior auricular nerve, the facial nerve gives off some motor branches to the posterior belly of digastric and stylohyoid muscles.
And then it reaches the parotid gland, right?
Right, but super important. The facial nerve does not innervate the parotid gland itself. It just passes through it.
And it gives off branches there.
Yeah, inside the parotid gland, the facial nerve splits into 5 big branches. And you can remember them with the mnemonic to Zanzibar by motor car. T for temporal branch, Z for zygomatic branch, B for buccal branch, M for marginal mandibular branch, and finally, C for the cervical branch.
Nice. And these guys are responsible for moving all the muscles of facial expression?
Exactly. Smiling, frowning, raising your eyebrows, puffing your cheeks. All facial nerve branches.
We're almost done. Let's do a quick recap of the facial nerve. It moves the face, closes the eyes, and innervates the stapedius muscle. It also takes a taste from the interior tongue and helps us tear up and salivate from our glands, except from the parotid gland.
Yup, and the facial nerve is the real VIP when it comes to facial expressions.
I think we should quiz our PodBiters now.
Let's do it. Which branch of the facial nerve carries taste fibers from the anterior 2/3 of the tongue? That would be the chorda tympani branch, which eventually joins with the lingual nerve.
All right, everyone. That wraps our deep dive into the magical world of cranial nerves 5 and 7. Thank you for joining us, Amro.
Thank you for having me.
We hope this helped untangle some of the complexity around these two nerves. If it did, share with a friend, leave us a rating, and stay tuned for more episodes where we make medicine just a little more fun. Thanks for listening to PodBites. We'll catch you in the next one.